Hello everyone, Jai Jagannath. I am Jasmine here. Welcome back to my channel, Take on Beyond with Jasmine. In our last series, we discussed about SQL function, where we cover its definition, types of function, and its uses with business case studies. Here I highly recommend whoever did not attend my last series, just go back and watch the series so that you can get thorough idea before getting into a new topic. So, without wasting time, let's start our today's session where we are going to cover a very important topic in the SQL. SQL will be incomplete without that topic. That is about SQL Join. So, let's start. So, SQL Joins. What it means? Definition. It says SQL join is used to combine the rows from the two or more tables based on a related column between them. And its syntax will be like select columns from table 1, join table 2, or table 1 dot common column equal to table 2 dot common column, ended with a semicolon. So, if we will break down, then it will be like join. Join means whenever we are relating two or more tables. Till now, whatever we discussed, that was about a only single table. Now, we are moving towards a more than one table. So here, when the concept of two or more tables, that time SQL joins will come into our mind. So it says about like relation, how that relation between two tables will be existed. Only because of common column we can relate two tables, and that relation arises due to key column. That is nothing but about primary key column. One is the second one is the foreign key column. If you have remembered, already we covered about this key column in our SQL constraint topic. So here syntax is saying like select columns from table 1 join table 2 on table 1 dot common column equals to table 2 dot common column. So as we know, if we see our standard order in the SQL, so this standard order of the SQL clause will be what? Like SQL standard order that starts with select, from, join, on, where, then group by, then having, then limit. If you have remembered, our standard order of SQL clause starts with select, from, then join, then on, then where, then group by, then having, then limit. Okay, so in this order, every time we'll have to code or write the queries in SQL. Whenever as we are discussing about SQL joins. So the order will be in form of select, from, join, on. So this much till on we need. Okay. And here I would like to mention this common column will be is nothing but our primary key and foreign key concept. Okay, and mostly this on condition will be based on foreign key constraint. Okay, and here first we'll have to identify the table through alias. Okay, so table 1, table 2, that doesn't mean two different tables, and we'll have to identify these two tables through alias. Okay, and then we come back to our table 1 and table 2. Okay, so through the alias name. Okay, and then these columns will be identified by the this table alias. Okay, like suppose if I will take that table 1 as like T and table 2 suppose S, then here whatever column we want to display or retrieve, we would recognize through the alias, like your table alias name dot this column name. Suppose table 1, which column you want to retrieve, so T dot column 1 or column 2, then comma, again table 2, which column you want to display from the table 2, then S dot this table 2 alias name we have given like S, so S dot column 1, column 2, like this. Okay, so slowly we'll cover up. No worries for that. Okay, and here the concept of primary key and foreign key. That means suppose one table is there and one more table is here. Okay, so suppose table 1, here table 2. Okay, and table 1 is having few columns, table 2 as well having few columns. Suppose this in these two tables there will be one column which will be common. Before to that, I would like to mention like table 1, each table will be identified by the primary key column. That primary key is nothing but your unique number. And table 2 as well, here also table 2 will have one unique ID number, that is the primary key column. Okay, but one more column which is going to be common, that is our foreign key. Okay, so hope you got it. So SQL join is the combining the rows from the two or more tables based on the related column between these two tables through the primary key from one table and a foreign key from another. So that foreign key which is the common. Okay, in table 1, this primary key column is going to be the foreign column for the table 2. So table 1 here is the your parent table and table 2 will be your child table. Okay, so in that child table, table 1's or parent table's primary key column is going to be foreign column. So this foreign column will be relate to the table 1. Okay, so no worries for that. We'll cover up. So now it says about types of join. So we cover like what join means. Now types of join, what are the different types of joins are there? So it is inner join, left join, right join, full join, cross join, self join. So 6 types of join we are going to discuss. So inner join, what it means? Inner means what? Like suppose two tables will be there. If we'll see in our Venn diagram like table A, table B. So inner means which is the common in between two tables. Okay, it is nothing but our intersection part. So returns rows that have the matching values in both the tables. In both the tables, matching values. Okay, that means common. Okay, so returns matching records only. So these intersection parts it will be written. And example, like whenever we are asking for like active customer, suppose in a customer table and there is a one more other tables are there, so active customers we want in between two tables. Okay, left join or left outer join, what it says, returns all the rows from the left table and match the rows from the right table. And what it returns in the output, all left from the left table plus your matched with the right table. If we'll see in the example, we can say all customers including inactive. Okay, right join or right outer join, it returns all the rows from the right table and match the rows from the left table. Just vice versa to the left join. All right with matched from the left table, it will give in the output. If we'll see in the example, we can say all orders including the unmatched. So this left join and right join just a two opposite sides of a coin. They act like just two sides of the coin. Okay. So here, if you will see from the example, like all customer including inactive, here we are looking at like all orders including unmatched. Okay. So then full join returns all the rows when there is a match in either left or right table. But it returns in the output all rows, like it may be matched or unmatched, and it will give the combined report. If we will see at the cross join returns the Cartesian product of both the tables. What it does, it combines all the combination it will take for the testing scenarios. That use case will find in the testing scenarios. If we look at the last join, this is the self join. Self means a single table or the same table, how you are making the relationship between table and itself within a table. Joins a table with itself or same table join. And in output, what it returns? It shows the hierarchical comparison. Okay. And goal also hierarchical comparison. Cross join we are using for the testing purpose, and self join hierarchical comparison. Okay. So just go through it and slowly explain all this. So inner join you got like intersection part. Okay. If table 1 and if the table 2, then inner will be like intersection part. Okay. Which is the common in both the table. And the left join, what it says? Left side, right side. Okay. So it says it will keep the records from the left table completely. Okay. And then it will match with respect to right table. Okay. That means it will keep all the records from the left table, then only matching records from the right table it will take. Okay. Just flip the table, it will give you right join. Okay. Suppose in a new table I am taking, and this is the suppose right and this is also a left table. So what it will do, it will keep all the records from the right table, complete right table. Okay. Complete right table records it will keep. With that, it will take the matching records from the left table. Okay. That means this part. Okay. I already covered. And then full join. That means it will take all the records. Okay. From both the table, it will keep all the records. Then cross join, like it will take records from the both table, it will match row to row connection, and then self join within the table it will join. Okay, mostly hierarchical comparison. If we will see like employee manager relation, whenever any hierarchical departmental corporate departmental hierarchical order. Okay, so wherever any subordinate and subordinate relation are there, we are going to choose self join. Okay, so just go through it. So now is the complete diagrammatic representation of the different types of joins. We can say it is the Venn diagram. Okay, so see, inner join example. Suppose table employee, and here this table is the department. So inner join will be like this middle part, common part. Okay, and full join example, if you see, complete both the table it will represent. Cross join example, like table employee and table department, it will combine the rows. Each row will be combined with the another table's rows. Okay, rows to row. Suppose this row 1 will be combined with all the rows in the table 2. Likewise, second row will be combined with the second table's all the rows. Third row in the table 1 or table employee will be combined with the all the rows inside the table department. Likewise, and vice versa, like from the table department, first rows will be combined with the for all the rows of the table employee, and same way all the rows will be combined with respect to another table's rows. Okay, and coming to left join, like in these two tables, like employee table and department table, if you'll see, so completely it will take all the records from the employee table and only matching records from the department, like this middle part only. If we'll see right join, just opposite to the left join, like it will take all the records from the right table and matching records from the left side. Okay, that means this part, colored part. Then last join, like self join, it's a single table, employee table, and inside this employee table, how we are making the hierarchical comparison. Like in that employee, suppose one employee column will be there and its ID serial number will be there and its a hierarchical ID number will be there. We'll have to choose who is the manager, how is the employee manager relationship. Okay, so this table, whenever within itself is the making the relationship, we are saying self join. Okay, and in this we are mostly using that left join scenarios in our day-to-day business scenarios. Okay, so left join is mostly commonly used, but each join type serves a unique purpose depending upon the what type of data we want to resolve. Okay. Then next, how SQL join actually work? As I told already, I mentioned that key columns is the key factor in this SQL join, that is primary key and foreign key. So when we are saying like primary and when is the need of the foreign key. So let's see, a primary key of the parent table becomes a foreign key in the child table. This relationship connects the two tables and allows SQL joins to work properly. Key columns in the joins, like two key columns like primary key and foreign key. Okay, so in a join, the columns used in the on condition, usually primary keys and foreign keys, play the most important role. If you see primary key, a unique identifier for each row in a table, and make sure there will be no duplicate in the record. Usually used from the parent table. If we'll example like a customer table, product table, we'll see in this parent table there will be primary key column. Okay, and what about foreign key? So foreign key is nothing but a column in another table that refers to the primary key of the parent table. Okay, make sure referential integrity between two tables and used to create a relationship between two tables. Usually it comes from the child table like orders table, order items table. Suppose if we'll take, there is a customer table, okay, like in customer table there will be like customer ID, okay, and customer name, and then suppose order ID, okay, and in its child table like order table, if we'll see, there is columns like order ID, okay, and then so order ID, quantity, and price, okay. So here you will see each parent table as well as child table, two tables will have two primary key columns. Like definitely every table will have a primary key column. So customer table will have a one primary key column like customer ID, okay. Here if we will come to order tables, definitely it will have also one primary key column like order ID. But whenever we are coming to the making relationship like joining the two tables, it will be possible only because of what common key columns. So which one is the common in between two tables? So this is nothing but our order ID. Okay, already we saw like here also this order ID act as a primary key column. Anyways, but this key column is common to the parent table. So this key column is referencing to the parent table. Okay, so for this child table, this key column will act as a foreign key for the table customer, okay, and whereas the customer ID will act as the primary key column for the customer table, okay, and order ID will act as the foreign key to the customer table. So on condition, whenever we are using the on condition in our query writing, that time it will be much more influential condition, okay. So based on that we'll match and make the different types of join, okay. Just go through it. So concept, what the key columns says and what they do. Primary key column, it is the unique identifier in the parent table, okay. Foreign key, if we will see, like it references the primary key of the another table in the child table, okay. So here as I told, like in customer table, that customer ID acts as a primary key column, but whenever coming to the child table in orders table, this customer ID acts as a foreign key columns, okay, and this foreign key column references to the primary or parent table, okay. So purpose creates the relationship between tables, okay, and where we are using it on condition. Basically this key column, these two key columns we are going to like primary key column and foreign key column we are going to use on condition, okay, in our join queries. Result what it gives, it combines the data from both the table on matched key values, okay. Suppose it will give take the sample example, like we'll see in the query how we are defining this key column in our coding part. So select that alias name we have taken like c dot customer name comma o dot order, o means order alias name, okay. Second table like child table orders, so o dot order ID from customer c, like from table 1 join table 2, okay. So customer C join orders O on this on condition C. So C means customer table like parent tables dot common key column, okay, and equals to second table like child table dot this foreign key column like customer ID, okay. This is the primary key column for the parent table, and this column is the foreign key column for the child table. You get it? What I mean to say. So select this like key column. We are going to retrieve like customer name, order ID, okay, and how we'll naming them through the alias, okay, alias of the table like customer. We have taken alias C, and orders table we have taken the alias for order table O, okay, and then as per our standard order of the clause is in the query writing we'll mention like select C dot customer name comma O dot order ID from table name, okay. So here the two tables will define them with join. So customer C join orders O, then on condition how will define, this is the primary table alias, okay, parent table alias, parent table alias. So parent table dot primary key column equals to our child table dot foreign key column. That means that foreign key column in the child table and this primary key column in the parent table, okay. And ultimately if we'll see this primary key column and foreign key column is nothing but the common column, okay. Only difference is the table, how we are differentiating common column. From the two table point of perspective, they varies in the naming, okay, got it. And then it says SQL looks rows where the so SQL will take the rows one by one through this condition, on condition. On is nothing but our if condition, okay. How we are making the condition whenever we'll study in Python, we'll see like if condition, okay. So SQL looks for each rows where the foreign key value of orders dot customer ID equals to primary key value of the parent table like customer dot ID, okay. So what is the purpose, why we are taking this join and this on condition and everything, why we are doing? So only because purpose is our making data integrity, join accuracy and query performance. So how data integrity will come? Make sure the relationships are consistent and valid, okay. So whatever we are creating the relationship, that should be valid, okay. And join accuracy, like it prevents incorrect or duplicated data from the mismatched join. How we'll going to differentiate it? And then query performance. So no doubt at the end it will give the proper indexed key that makes joins the faster. We can retrieve the data in a faster way. Okay. Go through it. Then move towards. So finally it's the inner join. As I told, inner join means it will take the records, matching records from both the table. If we see two tables, then only this middle part, this matching records. So you just tell me how the output will come out in these two tables. So given table is like one parent table and here one is the child table. So we'll have to identify which one is the parent table and which one is going to be the child table. So see, so suppose customer, okay. So first customer table and customer ID is there and customer name is there. And whenever their transaction is happening, of the customer is happening, okay. So this order, transaction of the orders. So it is going to be a child table. So this order table will have a primary key column like order ID, customer ID, amounts, okay. So you just tell me which one is the primary key column and foreign key column. So based on the table, we'll have to identify. So customer table, this customer ID is the first, we'll have to identify primary key column, okay. So for customer table, if we'll see, customer ID is the primary key column. Coming to the second table, orders table, that child table. Okay. So order ID is going to be the primary key column for the order table. Okay. If we'll see that, but how the table is going to be interrelated or joined? Only if we'll find the common column. So customer ID is column in between two tables. Okay. So this customer ID is the foreign key in order table. Okay. Okay, you got it. So this condition we got, that customer ID column is the column common in between two tables. But in parent table, it acts as a primary key column because it is the origin is there, but migrated to only child table. So that's why we are saying foreign key column. Okay, in child table. So now how the result will come? So what we will have to do? As we know, inner join will take the only middle part or combined or matching part only. So based on this common column, we are going to identify the customer name with order ID or amount what you want. Okay. So based on the questions, we'll have to retrieve the record. So if we'll see like customer ID 1, 2, 3, here 1, 2, 1. So common in between two tables are 1, 2 and here also 1, 2, 1. So based on this column record, we'll have to analyze the records. So 1, 1, here also 1, here also 1. So 1, if we'll see 1 as the parent table, 1 is the name Analyst. Okay. So and here if we'll come to 1, that order ID and amount will be with respect to Analyst. Okay. So Analyst order ID will be 101. Okay. Same way, second order second ID, if we'll see, name is the Bob. Okay. So mention the name Bob, and then this 102 and 300 is related to 2. So accordingly order ID we want. So that's why 102. Same manner 1, because we want only common records. So 1 is there common. So this 1 is in whose name? On Alice's name. So Alice. And this Alice ID, order ID is going to be 1, means this 1 is matching to 103 with amount is the 200. So 103 we need. After the result will come name and order ID. Okay. So whenever any question will come based on the join, first you will have to read it and then break down and then choose the which one is the primary key column and foreign key column in different tables. Then after go for the condition. As I told, like how we'll choose the condition on condition, like customer first parent table's primary key column equals to child table like orders dot foreign key column. Okay. So here customer dot ID and here orders dot customer ID. Okay. And based on that only we decided, suppose 1 to 1 we check and then we analyze the name and order ID. Okay. Then let's see it is the next. So inner join, what it says, only matching records. So if we define, then returns the rows where there is a match in both the tables. If we'll see the business scenario, then question will be like, show the customer who have placed orders. So you just tell me how to break down. So positive, like customers and who have placed orders, like it is also positive. Okay, customer and placed orders. Like if we'll see positive side. Okay. So what we will have to do, just inner join we'll have to make, because customer and who is having also orders. So this middle part. So as per our standard order of the SQL queries, we'll have to segregate, like first select how to segregate or break down the queries. So select, then first for the retrieve the column, we need to choose the clause select, then from where, that table name. So from means table. So here, though there are two tables, so we'll have to identify table 1, then join. So here join means inner join, okay, and then table 2, okay, then on, then parent table with primary key column equals to child table with dot foreign key column, okay, then semicolon. So if we'll see, like here it is saying customer and who is having placed orders, okay. So customer will have, we saw that there is a customer ID and one is the customer name, okay. So we want to identify that name and order ID. If we'll see here, like a customer name and order, who has placed the order, that is nothing but about your order ID, okay. So as I mentioned that first we got the standard order, then we'll have to just give the alias to the tables, first alias to the tables. So here from side the table 1 and inner join with the table 2. So this table 1 is nothing but our customer table, and then table 2 is nothing but our orders table. So this customer table will have to give the alias C, and customer table 2 will have to give the alias like orders O, okay. Then come to condition, as we know that once table we give the alias to the table, then simply select side column retrieve that table alias name dot column name, like customer name and order ID, okay. Then from table identification dot, then our on condition also we did it. So if we look at the proper query, then it will become like, select C dot name comma O dot order ID from, then table as I told customer alias inner join orders table 2, like child table orders alias O, then on condition, and that condition parent table we cannot make it so long, so that's why we are using alias. So C dot customer ID, that primary key column, equals to that child table alias like O dot that foreign key column customer ID in that child table. This belongs to the child table and this belongs to the parent table, okay. So just check, and what it will give the result, only customer with orders are shown based on the common column match, okay. If we'll see also here, if we'll see, I already created that table, okay. So customer table I created like customer ID and then data type, then our constraint, okay. Then second column name, it was name, and then name data type like Bhairkar, and then I inserted the values, okay. Why I am showing here, because the tricky part is in the child table creation, because foreign key concept is there, okay. So then I executed, you can see, yes, see, just a match, okay. Customer 1, 2, 3, Alice, Bob, Charlie, okay. Alice, Bob, Charlie, 1, 2, 3, okay. Then our order table here, just see, create the create table name like orders, okay. Inside the bracket, what are the key columns, okay, order ID, comma, that customer ID, and then amount it was there, okay. So order ID, it is a data type int, then it will be the primary key column in that order table, okay, comma, then customer ID int. Here is the tricky part, it should be like mention constraint foreign key, but as it is the referential integrity, so how we are going to use the key what I will tell. So it will, here we are not going to mention, okay, just let it be like customer ID and int data type, okay, and comma, then third column it was amount, then data type decimal, and then it's a total and precision, okay. After decimal, how much, how many digit we want. So 10 comma 2 I have taken, then comma, here is the tricky part. So foreign key, okay, foreign key within bracket that common column, which column is the foreign key that we are going to refer. So customer ID is the foreign key column in the child table, okay. Reference is that parent table with common column name, okay, that primary key column name, customers within bracket customer ID, okay. Then as usual inserted the values to the order table, like then structure, then values, okay. I got, okay, that 101, 102, 103, 121 and 500, that amount you just cross it, okay. 101, 23, 121, 500, 300, okay. So now as per our question, so the customer who have placed orders, okay, that customer side is the customer and place side also order, both we want, okay. If you see like customer and orders, here also positive side, here also positive side, so we want middle part, okay. As I mentioned, as per our clause, select, okay, select we want, then from, then table it will be there, but this table here it is a dot join two tables, so concept of join, and then types of join, which one, inner join, okay, inner join, then table 2 will be there, then our on condition, okay, on condition. So first what we'll do, from which table we want, okay, already it is there customers, and then your orders. As I mentioned, customers will have to identify through the alias C. Then as well as child table will have to read through the alias O, okay. Then on part we will take condition. What is the condition? Like first our will be parent table alias C dot common key column, it was there like primary key column name customer ID equal to child table O dot foreign key column is nothing but same as the common key column customer ID, then semicolon, then which column we want to retrieve, okay. From the first table we want, it was like name, comma, from the second table we want order ID, okay. As I told, every time we will have to identify through the alias, so O dot order ID as well as name also C dot name. So we just cross check, it was customer ID or customer name, right. Select C dot name, any space maybe, C dot name, comma, O dot order ID from customer table C, inner join orders O on C dot customer ID, O dot customer ID, okay, done. Why it is not taking, showing red color, let's see. Anyways, our query is executed, okay. So Alice Bob 101, 103, 102. Alice Bob Alice 101, 102, 103. Okay, got it. So every time we will have to just break down the question, and then as per the logic we'll have to write the queries. Okay, so be logical, be practical whenever you are writing the queries. Okay, got it? Then come to our left join and right join. Before getting into left join and right join, I want to make you clear that be clear in the concept what is left table and right table concept. Okay, so look at the Venn diagram here. Already I told you, here is the table, complete table, that is the left table, and this part is the right table. Okay, but how to identify the table you write first before join keywords is the left table, and after table you write after join keywords is the right table. Okay, but looking at the situation of the question or scenario questions, we'll have to identify which we are taking, left and right. But if we'll see, most of the cases we are going to use left table. Okay, if we'll see the syntax, then as I told, like select columns from table A left join table B on table A dot id equals to table B dot id. Okay, but here how to identify this? Because table, two tables we will get after from clause. Okay, so in between these two tables, which is the before join clause, like keyword join here. Okay, so before this left join, which table name is there? Table A. So this table A is your left table, and after join, which table name is there? This is going to be your right table. Okay, so here table A is the left, here right table is the table B. So as per our join concept, suppose in this statement I am keeping left table and right table. So in this right join, here right table take all the records, and from the left join it will take all the records from the this left table. Okay, so if we'll see like sideways, like left join, what it will do, it appears before join. Okay, and always retained fully in the left join. Okay, and right join just opposite to it, appears after join keyword, and only matched rows are kept in the left join. Okay, you got it? No worries. Coming to the next slide, you can get the clarity. Left join, what it says. If we'll see left join, what it will do in this two table, if we'll take this side is the left table, then it will take all the record from the left table, and it will take, in addition to this left table record, it will take only the matching record from the right table, this part. Okay, which yellow color is inside that blue, this part it will take, and which one is not there, it will take as the null value, looking at the left table row. Okay, so how it defines? Return all the rows from the left table and matched rows from the right table, and unmatched right side rows return as the null. So what it means, unmatched right side rows, that is nothing but our rows in the left table with no match in the right table shows null for the right table columns. Okay, if we see as the scenarios, you can get clarity. List all the products even if they have not been sold. Okay, suppose whenever in our e-commerce site, any Amazon or Flipkart orders, you can just analyze, you can get the fundamentals. So what it says, list all the products. Suppose there is a product table, and one more table is there, which one, even if they have not been sold. That means we can say order. Okay, order items or sale items. Okay, so here is the product table. Okay, is the product table is your parent table, and order items it is your child table. Okay, so suppose here is the product table and here is the order. You decide first which one you want to keep. So as we know, that list all the products, okay, list all the products even if they have not been sold. So positive side, like all the products. So as we know, left side keep all the records. So just matches similar concept, like all products. Okay. So if we'll take, this is the left join concept we are saying. So all side will take as the left side table. Okay. So this is going to be the product table. So it will keep all the records from the product table. And even if they have not been sold, so north side, that means opposite, like order items, it is going to be ultimately right table. Okay. So you got the table, which side. So now, as per the, if you see the queries, how we are going to get the outputs by using the queries. Okay, left join queries. So let's see. So select, as per our standard clause, we will mention select from, then our table, how the table will be mentioned through the join concept. Okay, then our on condition as usual. So select which column we want to retrieve. It says all products. That means if you see under product, there will be like product ID and product name. Let's see where you can get the clarity looking at the questions. Okay, so list all the products even if they have not been sold. Okay, so one is the product table and here is the order items table, and already we categorize which one is the left table and which one is the right table. So here I have mentioned like left table, product table as usual, parent table from the looking at the question scenario, like all products. Okay, and then it is going to be a right table, and what is there inside that entity, like product ID and then product name. Okay, and here what is the entity, like order ID, one is the product ID. Okay, so you just tell me which one is the primary key column and which one is going to be the foreign key column. Okay, so if we'll see for the product table, product ID is the primary key column. Coming to the child table, if you see order items table, order ID is the primary key column for the order table. But we don't need from the child table primary key column. We need which one? Foreign key column. So foreign key column is the product ID. Okay. So what left join says, it will keep all the records from the left table. So as we want all the products, so besides product ID, we want product name. We got one retrieve part. Okay, product name. Select product name, it will be there, and then even if they have not been sold, so one is the order ID. Okay, select part is done. Then from what it will take table always. So though it is the two table and concept is the left join we knew. So products left join order items. Okay, here most importantly we'll have to name the alias. Okay, that product will give the P and order items will be O. So here also retrieve part we'll have to mention through the alias P dot product name and then OI dot, suppose here OI order items is there. Okay, OI, so OI dot order ID. Okay, from part is done. Now join also done. Select from, join done. On part it will take as your first parent table, that alias we have taken like P dot primary key column like product ID. Okay, equals to child table who, that OI dot that foreign key column like product ID. Okay, got it? So what it will do, first it will SQL, if we'll see on these queries how we'll identify. So always it will start from this side. On is the if condition. Okay, so product ID. Okay, it will keep all the records from the left table. So first what it will do, it will take all product name in the result table. Okay, product name we got it. Okay, now what is to get order ID? How we will get? Through this condition. Okay, suppose parent tables product ID 1, okay, equals to our child table product ID like 1. Okay, here also 1, here also 1. 1 1 equals to, it is fine, then done. So 1 is the laptop, 1 is the 5 not 1 is the order ID. So we got laptop. So this laptop's order ID is going to be 5 not 1. Then coming to, it is done. Then if it gives the result, then coming to next, it will be iterated. So second 2, okay. So 2 from the left table, because it will take all the records from the left table, and then we, in addition to that, it will take matching records from the right table. So how it will match? Through the common column, okay, like how we are doing through the on condition. So 2, okay. So this 2 is mouse, it is also there. Then this 2 is in child table, if you see, it is also there common. So this matching record 2 will take order ID 502, 502, okay, done. Then come to the our third row, keyboard, okay, because it will take all the records from the left table, okay. So keyboard, so first keyboard's primary key column, that, okay, keyboard, it is the product ID 3, okay, this 3. If we'll come to child table, this product ID will see. Here nothing is there. So what it will do, whenever any matching records will be not there in the right table, it will take as the null, okay. So here what it will do, null, then stop, okay. So you got the fundamentals, okay. So now you just see the process. So SQL starts with the product, first left table takes all the rows from it, okay, we did it. Then it tries to match the each product with its product ID in order items right table, okay. What it will do, first match the each product with its product ID in order items right table. How we did it? Through the product ID, okay. If it matches, then combines the columns from the both the table. How we did it? And then if no match, fill the columns from the right table as null, okay. Got it? So here just we have taken very less records, so you are easily analyzing and getting the result verbally. But whenever any big data size, so we'll have to take the help of this SQL queries, and through the SQL we will have to execute, okay. So how will be our queries? As I told, let's see, select P dot product name, okay, OI dot order ID from product P, left join order items OI on P dot product ID equals to OI dot product ID. So left table products, all rows always appear. Right table order items, only matching the rows appear. Join condition, like this on condition, okay, through the primary key column and foreign key column. On matched rows, what it will do, from the right table, it will show as the null on matched right side, okay. And what it will do in our business, if you see, it will detect the products not ordered yet, because even if they have not been sold, so it will identify which one has not been ordered yet, okay. So it will detect the product. What is the benefit of left join? It will detect the product which has not been ordered yet, okay. So we'll see in our query execution part, okay. Left join, where it is, so yes. So as usual, I created the table. So this product table you can make easily, but coming to the child table, how that foreign key part, that foreign key bracket, our column name, then references, parent table with primary key column, okay. That is the only tricky part you will have to remember while creating the table of child table, okay. Then insert the values as usual. Then coming to the query execution part, list all the products even if they have not been sold, okay. So when all products, this side I want to keep left table, okay. So select, then from table the products, just check the products, yes, products, alias will be like P, then left join, and with which child table order items that will take the alias OI. Other items OI, they on condition on how will mention parent table dot primary key column. Which one is the primary key column? That product ID equals to child table OI dot foreign key column. That foreign key column is nothing but our primary key column. Okay, product underscore ID. You did it, condition part is done. Only last part is the retrieve. Which one we want to retrieve? From the products table, we want to retrieve product name, p dot product name, because the list of all the products. So product name, comma, child table, which one we want to do, even if they have not ordered, that means ordered, we want order ID, OI dot order ID. Already it is, okay, done. Everything is done. Offset. So now we'll execute. Just cross check. Select is there, our from also there. Left join we did it. On also we did it. Okay. This. Every time we just cross check, then we will execute. So laptop, mouse, keyboard. This it will take all the records from the left side table and the matching records from the right table. And when unmatched, it will put null. Okay. So check if you are 501, 502, then null. Okay, done. Then coming to the right join. It is just opposite to the left join. What we did, just opposite. Okay. So it will take all the records from the right table with matches from the left table. Okay. Returns all the rows from the right table and matched rows from the left table, and on matched left side rows, it will give the null. On matched left side rows, return null. That means rows in the right side table with no match in the left table shows the null for the left table column. Okay. It is the mirror image of the left join. Both are used to include unmatched data from one side. So how to identify that it will take left join or right join concept? Whenever the concept like unmatched data from either one side. Okay. Because two tables, definitely it will ask for all the records from one side table. Another side it will ask for like unmatched. Okay. That time one side positive, one side negative, either or this side, first side will be negative and the another side will be positive, either or situation. That time we will take the help of right join or left join concept. Okay. So let's see how it is executed in business scenario. So question is like list all the orders even if some don't have matching product details. Okay. Here one question will come into your mind, like in our previous question also we did in same manner, like list all the products which has not been placed. So there we took that products table as the left table, but here how we are going to take orders table as the right table? So in simple manner, there we took first that product like parent table as the left table. Okay, and another side automatically child table we took right table. In that note, we'll keep here also same manner, like parent table will keep left side and the child will keep at the right side. So this right side table will be considered as the right table. Okay, and so here you will see like list all the orders. Okay, so all orders means this side order is there like right side. Okay, concept is very similar, so you should not get confused. Even if you want to take left side also you can do, but here I want to show you in right join concept. Okay, so suppose here order table, that child table I have taken right table, so I want all the records from the order. So order is in right side, so I will take all the records. All order means all, right side table all. Then even if some don't have a matching product details, with whom it will match? Product, like left table. Okay, even if there is no Q will be matched, P will be unmatched, so it will concept right join. Okay, so as usual it will take select, okay, then from, and then join the table. Okay, then on condition. Okay, so first from the table, because we will have to give the name through the alias. Okay, so table, two tables like product parent table, join with the, and the concept is join is the right join, so I will mention right join, type of join. Okay, then right join product I take P, and then our another is the order. Okay, same I will take order or order items what you want. Okay, order item OI. Okay, done. Then on part, so how we'll give the on condition, that parent table P dot primary key column. Which one is the primary key column? Question will be there surely. So product table, and here is the other items table. So as I told, product I have taken parent table as the left table, and here child table I have taken right table. As we want all the records from the right table, so right join. Okay, so this right table, all the records like order ID, quantity, and product ID. So though it is the product ID, condition will be on the on condition. So product ID. Okay, so on product ID is the primary key column. So primary parent table P dot primary key column is the product ID equals to our child table OI dot foreign key column is the, in the child table, which one is the foreign key column? Product ID. Okay, done. So which one we want to retrieve? First we want to retrieve all the columns from the, like all the records from the right table. Okay, so that order ID, so OI, that child table alias OI dot key column name, sorry, like order ID we want, then OI dot quantity. Okay, comma our from the parent table we want P dot product name. Okay, come to the question side, you will visualize and analyze. So tell me, so here product ID is there, and here also product ID. So this product ID for the parent table, it will act as the primary key column. Coming to the child table, this product ID will act as the foreign key column, and order ID act as a primary key column for the child table. Okay, so here if we'll take the, as we want all the records from the order table, so we'll keep order ID and quantity. Okay, now what we'll do, we'll have to take matching records from the left table with this, all the records from the left table. Okay, so see how we'll do. On condition here we'll put. Okay, so check first, you will take the records order ID. Okay, keep all the records, then quantity also keep all the records. Done, everything is done. Now what is the result part? Like product name we want from the parent table. Okay, because even if they have not matched product details. Okay, so product name, if you want also price, you can put as your wish. Okay, so product name will keep. So let's see order ID. Okay, matching to the product ID. Okay, 5011. This one coming to the parent table. Okay, 1 equals to laptop. Okay, done. So you will keep 1 laptop. Okay, and quantity 3 also. 1 is matching to 501 and 3. Then after we went to 1 here. This is laptop and 60,000. Okay, done. So 502 is related to product ID 2, because our on condition every time we should remember. Okay, on condition is the parent table P dot product ID, that primary key column equals to child table is OI dot product ID foreign key column. Okay, so now what we are doing, keeping all the records from the right side table. Okay, so this right table is the OI order item. So this order ID primary key column, sorry, foreign key column, like 1, 2, 4 is there. Okay, so now we'll have to match with what? With the parent table's primary key column. Okay, like primary key column who are there? 1, 2, 3. But here we want all the records from this side. Okay, so that's why we'll start from this side. 1 coming to this side. So here 1 is the 501. Then after we went, 1 is the here also matching. So laptop is there. Done. Then coming to the 2 matching. 2, 2 matching. Okay, here also match. So these 2. Let's 2 is the mouse. So keep. Then come to which record? 4 is there. Come here, 4 is not there. So this 4 like 503, what will make? Null value. Okay, and here 3 we don't need. Okay, only we need all the right table record, and then this right tables record we will match with the left table. If it match, then it's quite good. If not match, then we'll take null value. Okay, you got it. 1 is matched to the parent tables 1. So that's why we took the value laptop, name laptop. Then 2 match, we took mouse. 4 did not match, that's why null. Okay, got it. In this way, we'll have to, based on the condition, logical way, you will have to analyze and get the result. If we'll see the step by step, see products. First, we'll have to choose, analyze which table, left side and right side table. Okay, product is the left table, order item we took right table. Then SQL keeps all the rows from the right table. As we know that right table data, order ID and quantity. Then it checks for condition like order items dot product ID has a match in products dot product ID. Okay, that order items. First, it will take all the right side, then match with the left side. If a match, then show product details. If not match, then it will take null. Okay, here it mentioned like order 501 and 502, they match, like 1 and 2, they matched. Okay, that's why these two parent tables record. And when not match, like 503 not match, so that's why it gave the output null. Okay, finally our output is the laptop mouse null. Okay, it will execute. Right side. Okay, in similar way we'll do list all orders, even if some don't have a matching product details. List all orders means here, though I want to show you in the right chain concept, that's why I will do. Otherwise, any of like whenever one side positive like all, another side is may or may not, then concept of left chain or right chain. But how you are taking, that depends upon you. If suppose one statement list all orders, suppose I will take here left chain, that is also okay. Okay, order side will take left and this side product side will take right table. Accordingly we will do. Okay, so select from table is the same table we'll do. Okay, and then one thing, your concept of right join. Okay, right will mention order items, it is same. Alias, okay, first from side will start like from table name, alias done on same parent table with primary key column equals to child table with foreign key column, done. Then retrieve part, which one? List all orders. Here little bit changes we'll have to do. First we'll keep all the records from the right side table, like it was order table, order items. Okay, order items. Okay, leaving only product ID, we will keep all the records like order ID. Into that order ID will keep. Okay, here only order ID is there. I have not created another table for right chain, so in this we'll see how is the result coming. Okay, if I want to show, so OI dot order ID, and then it will match with the left table, like the product table, products, what it is there, product ID, product name. Okay, so we'll keep product name. So P dot product name. Okay, done. We'll execute. Let's see what is the result is coming. So if we'll in the same table, if we will do, the result is showing order ID, right table record like 501, 502. It is only laptop mouse. Okay, there is no question of one side null or nothing. If you want to see which one is our this question, I make it right join concept. Okay, same table. Okay, if we'll see also in this our manual way, we'll see right table. Okay, it will keep all the records from the, if we'll do right join in this question, so it will keep all the records from the right table. Okay, leave the product. It is the foreign key column. Here it is the primary key column. Okay, primary key column. Here it is the foreign key column. So select how it will happen. Select order first. Go to right side table. It will keep all the records. So order OI dot order ID, comma, then left side table, only product name is there. Okay, so P dot product name. Every time you will have to identify through the alias. Then select part is done, retype. Then from two tables like you got what I mean to say. Okay, so select is done. Then from part, from our P products first table name, from products, it is the alias will be P. So that's why I'm saying every time you just first give the table name, then alias, then go to the other parts, so that it will be easier for you to segregate. So from products P, right join table, two tables will come. So order items OY. Okay, then done. It is join done, right? Then on condition will be like parent table P dot product ID equals to your order items dot foreign key column product ID. Okay, got it? So on that note, you will see like first it will take all the record from the what order ID, and here will be our product name. So 501, here will be 502. Okay, it is done. This part is done, result part. Okay, then we want to discover which one will be the product name as per our order ID. Okay, so come to condition. So first what we'll have to, how to analyze from the right side. Okay, so here is the right side, order ID, order items. Okay, so product ID 1 and 1 is the 2. Okay, we'll have to match. So how? We'll have to take all the records from the right table and match with the left table. Okay, so order ID 1, here what is the order ID 1, 2, 3. So 1 is matching 1, 1. Okay, so this one is the which name? Laptop. Okay, so laptop. And then 2, if we will take here 2 right side, then this 2 is matching this 2. Yes, it is matching. So this 2 is on which name? Mouse. Okay, so mouse. That's it. Only keep all the records. If suppose there will be 4, 5, then it will take as null. Suppose if there will be 3, then 3 is matching. So it will take keyboard. Okay, got it? Likewise. So answer will be only 501, 502 laptop mouse. That also we got in our output. Okay. Then move towards our next join, that is yes, one more thing. And right join, how it helps, it detects the data issues like order leave to missing or deleted product, and review incomplete order entries, maintain data integrity between the sales and inventory system. Okay, whenever this left join and right join, it mostly act in the detect the data issues, any mismatch or missing deleted product. Okay, Then come to next. Here, simple same way, left chain or right chain, how you will analyze. Like list all customer and their orders, even if some customer have not placed yet. One side is they want all, another like not placed. Okay, either or situation. That time you will take left chain or right chain. That's up to you how you are going to choose. Always try to keep all side like parent table, left chain, then accordingly just do. Okay, left chain return all the records from left table and matching records from the right table. Okay, and right chain same way. Functionally they are mirror image each other. The only difference is the which table is data fully preserved, like list all. Wherever concept of all, that means it will preserve this side table. Okay, how you are choosing the tables. Okay, so mostly keep parent table on the left side, but every time you cannot take looking at the questions scenario, you will have to choose. Then full outer join or full join, it means it will take all the records that may be matched or not, returns all the rows from the both the table. Where there is no match, nulls are returned. If we will see in our business scenario, question will be like reconcile customer and order data to find mismatches. Okay, so that time we will take mismatches. That means full join concept we can take. So here if you will see like two tables, so we'll take all the data so that we can identify which one is missing or mismatch any. So how it helps you just reconciliation. This helps you spot the customer who never placed order, spot the orders that references missing or deleted customer, and build audit or clean up. Okay. But here also I want to clarify full outer join, it will not be accepted or it will not be supported by MySQL. So why MySQL, what it does in the alternatively, it will take help of left join, right join and union. Okay, union of left join and right join, because customer and order data mismatch. How we will find? Suppose we will take one side all customer with missing data, and one more situation will take all the order data with few customers mismatch. So both then will addition like union will take. Okay. So here simply MySQL it uses combination. Okay. So if we'll see like customer with without order left join and orders with no matching customer, then union. Simple left join customer with without order. Suppose if we'll take this one left join, then ultimately we'll take right join like fully orders with no customer match. Okay. So the first query gets all customer even those without orders. The second query gets all orders even without matching customer. Union combines both the sets and removing the duplicate. This is preferred for the reconciling customer and order data to find the mismatches. Okay. So same manner like left join, you got the clarity on that. Okay, let's see full join on table customer and orders will do in simple way. Though we did both the scenario, here we did left join because same table we did it. I just mention here left join union, then right join. See, you got. So what it gives the result, like all the product name, all the order ID, even if any mismatch. Okay. Here you can identify why it happens because I have not kept in order. Okay, that's why. So first here I just opposite. If it will take, it is quite good. Otherwise, let's see. Okay, so same repetition was there. Concept is same, like laptop, mouse, keyboard, and 501, 502 null. It will give complete idea which one is the mismatch and any duplicacy or not. Okay, now next join, it is about cross join. Okay, cross join like Cartesian product. Okay, it means returns every combination of rows from both the table. Okay, business scenario, how it comes: generate every customer product pair for a marketing campaign. Whenever I already mentioned that whenever any testing purpose, we are taking help of cross join. Okay, because every time that does not usual scenario, but still we want to test it so that if some result will come. Okay, it is how I will show. Okay, suppose just see every customer paired with every product. That means here it has taken one customer table and one parent table product, two parents table. Okay, so used in the generating combination like potential purchase, what we basically here identify potential purchase, recommendation, example for testing all possible ways of the product customer pairing. Okay, so select that retrieve column name from both of the table, throw the alias name from table. Okay, here what we will have to do: simple table name cross join with the another table name. That's it. No condition, because it will take all the rows from the both the table and combine. Okay. So here our one, if I'll show you, already two different kinds of table we are doing. Like one is the customers. Okay. Customer table, and one more is the parent table is the products table here. Okay, so these two parent table will take under C. Select from customer cross join with which one? Products C. Okay, customer C. So here what we want, if I want to show you, see, select products. What is there? Product ID, product name. Okay, so product name, remember, we want E dot product name. Okay, because ID we don't need, we cannot do in that anything. So then customer table, if you will see, it is there and how we will combine. So same here also, one primary key column and one is the name only. So better we will go for name because two different parent table. So C dot name. Okay, because it will combine, it will taste. So if we will take all IDs, it will not be beneficial. So if we will combine with the customer name with the product name, at least we can get any dish in that. So we'll see. So this person has taken this product. Okay, you got it. Why I was showing that all combination you will get. Okay. So total result is, it is showing 10. Okay, it will come like 4 customer, 4 orders. So it is a customer and order it has taken. Okay, so it is showing 16. It will take the multiplication. That's why it has mentioned Cartesian product. Okay, then come to self join. So last join, a table join within itself using aliases. It is our self join. Okay, so only one table name is there, and in that table name, how we are utilizing another table within itself, that is your self join. and this one table it has taken. So we can join means two table concept. So how we are making this one table as a two tables using the aliases? Let's see. So business scenario, how it comes. Suppose departmental hierarchical comparison will do. Okay. So a company maintains a department table where each department may report to a parent department. You have been asked to generate a report showing each department alongside its parent department name. So your task is to write a SQL query to list all the departments with their parent department names. If a department has no parent also you show. Okay. So whenever concept of like subordinate and your boss, that time the concept of self join will come. Okay. That should be in your mind. So let's see. Question is there. Suppose one department, as we know that a company department table, each department, okay, may report to a parent department. So see, suppose how many departments are there? Corporate, HR, recruitment, finance, account payable, account receivable. Okay. So they are reporting to a parent department. Okay. Only single department will have to analyze, and department ID is there, and one more parent department ID is there. Okay. So first department ID is there, 1, 2, this is just serial number. It has taken 1, 2, 3, 4, 5, 6. Here it has given like corporate, there is no parent department ID because it is in the top department. Okay. Inside company, if you see like here, it is the corporate is the main department. So here no, for corporate there is no parent department. Okay. Coming to HR, the parent will be corporate. So it has mentioned 1. That parent department ID will be 1 because already department corporate ID is the 1. Okay, that's why 1. Then coming to the recruitment, it has given 2. Why? Recruitment is the reporting to HR. So HR ID is the 2. Then coming to finance, it has taken finance, it will report to corporate. Okay, that's why it has taken 1. HR will report to corporate, finance will to corporate. So 1. Then account payable, account receivable, they will report to finance. That's why 4. Okay, only that is the question. So how we are using, which one is the parent department name? Department name which is the parent department, how we will analyze. So we'll have to make the self-join name because already we knew it. Who is the whose boss or parent? Corporate null. And there will be top department will have no parent or no boss. HR will be the corporate, finance will be corporate, recruitment HR, account payable receivable will be finance. That is our output. So how will in the sample queries we got it, but whenever the data size will be bigger, we'll have to take the help of self-join queries. Okay, so that coding part we'll have to make. As usual, first select, okay, retrieve part, let it be, then from, here is the critical part. So self-join, when the concept of here self-join, but we will take help of left join. Okay, so why the concept of left join? Because I mentioned here all the records from the one table we will take, but the output side, you will see one will be null. Okay, like either or, q will be existed, q will not have. Okay, so that time either or situation will take us left join or right join. So here, though we are taking department side, one is the complete left table, so we'll better left join. Okay, most common cases will be on left join using. Okay, so left join. Okay, then table 1, like department already we knew it. Okay, department here, and one is the parent department. Okay, so left join department, here table name, first see what it is, departments. Okay, so accordingly departments, give the name as like D, and one more departments will be there like departments. Okay, here just look at the input table name. Okay, then alias like P. Okay, got it. Then our here left join done. Then on condition, what it will be, first table like D dot parent tables primary key column. Okay, parent table, you will see parent table P dot primary key column like department ID. Okay, and child table with foreign key column. Okay, or then retrieve part will be select what we want. One is the department. We want a name D dot department. This one department name we want as department. Okay, comma P dot like parent. Your department P. So P dot department name as we will give the name parent department. Okay, parent department. Okay, done. Now we'll execute. So just go through it and we'll execute. Okay. Here just tell me you got the table name. Okay, here it will be like act as a child table and it will also act as a parent table. Okay, and here for the parent table who will act as a primary key column. For parent table it will department ID. Okay, and child table who will act as a foreign key column. Okay. So just so you just tell me go to that mail. We'll have to execute. Select the departments. We'll see. Okay. Now what we'll do is select from departments. We'll give the alias like D. Left join will do left join with what departments P, and from it's done, then on condition on our parent table P dot, it will see like parent table who will be the primary key column. Okay, parent table's primary key column is the department ID. Okay, DPT ID. Okay, equals to D dot departments foreign key column. Okay, like departments foreign key column who will be like parent department ID, and then what we want, select D dot departments, what we want, departments D dot B dots department name B dot department's name as departments comma P dot P dot DPT name as P dot DPT name as parent department will take. Okay, parent department. So I think it's perfect. So here if you do this table DPT and here first table department table, if you see that this one will act as a primary key column, and if come to parent department ID, okay, and if we do, let's see, okay, I will tell you if we got the result. Yes, corporate is null, HR will be the corporate, for finance will be the corporate, recruitment will be yes. So then here you need to cross check like why we took left join condition and somewhere little bit tricky. Okay, where it is, yes, condition part, just check. If we'll see like completely this department, okay, and department ID, okay, so this 1 2 3 4 5 6, okay, it will act for the parent table, okay, which one is the parent table we'll have to consider from here only, okay. So for this parent table, it is the primary key column, okay. So coming to the department table, whenever the child table department name again, okay, so this parent department ID will act as the foreign key column, okay, that you should remember. This is the tricky part, okay, because you just see this corporate will act as the null, for HR will act as a 1, okay, and recruitment will, for recruitment HR will be the what, department ID, okay. So this parent department ID will act as the foreign key column for the child department table, okay. That's it. Hope you got the clarity, you got clear into that. So that's all about different types of joins, okay. So join type like inner, left, right, full, cross, self. So match the roles only both sides. So we can say active customer. If we'll take like one customer table and one order table, then left table will be like all from the left side and matching with the right table, all customer including inactive order, and right table if we'll say like all, it will come from the right table and matched from the left table, all orders including unmatched customer. Full table all from the both side, like it will give the combined report. Cross join, it will give, it will take all the combination like two different tables, how we'll do the combination, Cartesian product, cross product, okay, cross join, and it will do the testing scenario because two different parent tables we are doing. So it will do the recommendation or testing, and self, it will hierarchical comparison, same table join by using left or right join will do, okay. And here left join, left table, right join, right table concept, inner join like both matched, full join means from all the both rows, okay. Coming to the quiz part, what type of join will show customer who never placed an order? Suppose one side is like customer positive, one side is the negative. So it will be maybe left, maybe right. So better customer and order. So parent table means all sides. So left join it is, okay. If you want all data from both the table, then full outer join, okay, which join produces the Cartesian cross join. If you want to compare the employee to the manager, to the same table. So concept of same table and that to be comparison employee and manager. So join is the self join. What is the main difference between inner join and left join? Inner join will take the all the matching records. So where is the option? All rows. Inner is the matching rows and difference. Left join means from the all record from the left table and matching with the matching records from the right table. Okay. Hope you got the clarity. So just go through it. Okay. That part little bit tricky. You just remember. Okay. Don't be confused because very clear because two department table. Okay. So you just have to take which one is the primary key column and which one will be the foreign key column for the child department table. Okay. That's it. So this ID will be the for the primary key column for the parent table. Okay. And for the child table, this parent department ID will act as the foreign key column. Okay, that's it. These things you will keep it in the mind. I hope this video will be very helpful to you. At the end, I will say hope you will get clarity and it will be very helpful to solve any type of business scenarios. That's it for today. Just like the video, comment on it, subscribe the channel and share it with your family and friends and relatives. Thank you. Jai Jagannath.